Welcome everybody. This is a Python lesson for data analysis. Actually, it could be for anything. In this video, I will try to teach you the fundamental of Python. As you can see, I am at a Python official documentation or website. And of course, you can come to read also what it has. But now, actually, I'm here just to download Python. So I can download by clicking over here and wait for some time. Yeah, it will be downloaded very soon. And then I will do a couple of clicks. Then when you download, remember to tick this to add it to the environment. Then it will be available in every project when you do some projects. Great. Oh yeah, great. You installed Python. Now let's check if we really have Python in our machine. So just write cmd and then let's check if I have Python. You can write Python hyphen and version and check it. Yeah, I have Python version 3.95 and that's the latest version of Python. Okay, so how can I get started with Python? To make use of the Python, just you can write Python over here and this command will open the Python interactive shell that allow me to write Python code. Great. So as you can see, the blinker is waiting for you to write some Python code. It could be some calculation. Let's do some calculation because everybody loves adding numbers. 1 plus 2. And I think you may expect 3, right? 1 plus 2. As you can see, I didn't write it 1 plus 2 like this because sometimes spacing makes it easy for our eyes to read. It gives you 3, but it's nice when you write it like this. It's easy to read. Okay, can Python does also subtraction? Let's check. What's the difference between 2 and 1? And you may expect it's going to be 1. Let's do some multiplication. Multiplication actually is this the asterisk or the star sign, and then when you multiply 2 by 3, I think we should get 6. And then let's move on. How about if we divide 3 by 2? I expect 1.5. I hope you do the same. And then let's do actually floor division. The floor division, I will show you 7 like this. If I divide 7 by 4, I think there will be 1 and there will be 3 left over, right? So the floor division will be 1. What? So that means we just discard the remainder. The remaining we discard. Okay, how about if we divide 10 as a floor division by 4? Now 10 can be divided by 4 2 times, and then you will have some leftover or remainders, that is 2. Then actually we just keep the quotient. They call it in mathematics, I think it's quotient, so it's going to be 2. The remainder is also actually also 2 in this case. I will do more floor division to make this clear. For instance, if you do a floor division of 9 by 2, what it will be? I think you may expect it's going to be 4. I expect 4. Great. Now let's see modulus. A modulus is actually, it's the kind of the opposite of this. It's the opposite of floor division. Now we store actually the remainder. For instance, if you divide 7 by 4, the remainder is going to be 3. So we are more storing or saving the remainder. How about if we divide 9 by 4? This is going to be, I think I'm expecting 9 by 4. It's going to be 1 because 9 divided by 4, 2 times 4, 8, and then the remainder is 1. Yeah, that is maybe, I think we're about to finish to this. This is the exponential. We can make a power. For instance, if you want to make if you want to multiply numbers like this, 2 times 2 times 2, yeah? But sometimes we may make that shorter using exponential notation, and that is this, and it gives us 8. So when we make something exponent, actually we use 2 star signs. Do you believe that you just finished the arithmetic operation using Python? Yes, you did. But using the Python interactive shell, we don't use this quite often. Sometimes we just use this for just testing. So let's go out from this and install a code editor, and that's going to be VS Code. I love VS Code. And let's install VS Code. I installed VS Code 100 times with my students. Let me install this all over again, and just you wait for it for some time until this downloading is completed, and then we do the installation. Great. Yeah, I accept. And then you don't have to, it could be, I don't, do I need, it's okay. You can just install the default without changing anything, and it's okay. Great. You can keep this, or now it launch it as it because it's sticked. I will see. Yes, so clean. Let's look at it. So what is this? This new feature, it seems. Pick a theme. So this is completely different now, but it's okay. Let's see it together. These are just some notification. I don't like to see them because now, as you can see, getting started, because they have already some instruction what to do. Customize your setup, learn the fundamentals, boost your productivity. So maybe when you have time, also it's not bad to look at those kind of tutorials or documentation that help you to make use of this VS Code. Okay, now I don't like to see this page now and then. I will just make this untick. Great, and then buy. Great. So if you see, you can toggle over here by clicking. The settings over here, as you can see. For instance, if I want to change some setting, I can say theme. I think the theme is not here. Maybe the theme is just already here. Color theme. I am more of Dracula Soft. I prefer this theme. Yeah, you can come here and color Dracula Soft or official. I think the official is good. Yeah, and even you can search themes from here. Themes. So you can install the different theme if you want. For instance, I'm in favor of this, so I want to have it. As you can see now, I'm applying that. Most probably we have that. Okay, now I will show you how to use this. Now let's go to the desktop. Let's create a folder. I call it Python, like this. Great. So now you can put it anywhere, but I created it on the desktop. And let's go together and open that. Yeah, I think I don't like the way it's written. So let's just do a proper Python thing that doesn't really say Python. And select, but it doesn't matter if you made a typo or something. It doesn't really matter with the name, but just as you can see now, that folder is opened. You can give it any name. It doesn't matter if you call it Python or some tutorial or something. So let's create a file. I call this hello world.py. And then let's write our first code, print. Maybe I think it's hard for you to see. I can make this a bit bigger. Yeah, I think now most probably you can see it. Great. Print hello world. Yeah. Great. Now you can execute this. By the way, you come here, if you see this, and you can just drag it, and then it open this directory. So now you can write Python, and then the name of the file is hello world. So hello world. I use the tab, that's why I managed to write it fast. You can say hello and then click tab. Then the reason why I didn't see, because I didn't save it. So Control S, and now again I may run it. Hello world. Yeah, great. And now let's do more. Print hello. Can we write it separately? World. And then hello. I mean, is the quotation mark. Then again, Control S. Then you can get by the previous command this by using the up arrow, arrow key. Then yeah, I get the same. But nowadays Python is so smart. You don't have to write this. Just click this. Do you see this, the green button? Maybe if you don't have a green button, maybe you have to come in here and you have to install Python, some kind of extension if it's needed. So maybe you may not have this. You come to here, the extension, click over here and Python, then you should install this. After you install that, definitely you should see this green button. Okay, maybe what is this? This might be some features for VS Code. If we install it, we can just improve our productivity or linting. Indentation, so we don't have to worry about indentation, then this might help us. Just add to your thing. I don't know some of them by heart, but if I feel they are important, I just use them. The main purpose is just improve productivity. You don't do the boring thing by hand, okay? So it's already automated. So great. Now, can we do the same thing what we did before? Can we do some arithmetics? For instance, we did 1 plus 2, and we got, if you remember, 3. Now I have to save it, Control S, and then I can run this again, 3, or I can run it just from here. Sometimes it's jump, as you can see, I got 3. But if you have noticed, whenever I am like 2 minus 1, of course I'm expecting 1, but saving now and then is so tiring, right? So let's turn on the auto save. You can come here and then go to the settings again, auto save. Okay, you may go a bit down. And have you seen this? It's off. Let's turn it on. Maybe after a delay. After a delay, just turn the after a delay, then you changed it already. So there's nothing you can touch. So let's go out. After this, we don't think about saving. It will be saved by itself. Print 2 times 3, and you know it. And it should be actually 6. Let's see. Yeah, 6. What is this? Let's ignore this. Why not the first place? Okay, good. Now let's do also the division. Print 3 divided by 2. I think everybody knows it's going to be 1.5, and print 7 by 4. Maybe you tell me what's the division of 7? The floor division 7 by 4. It's 1. Okay, so let's see, but it's good to check. And then let me do more division by, for instance, 9 by 4. Now, as you can see, when you divide 9 by 4, it is 2 times, and the leftover or the remainder will be 1. So I'm expecting from this operation, I'm expecting 2. Yeah. Now let's see modulus 7 modulus 3. What's the remainder? When we divide 7 by 3, the remainder is going to be 1. And let's do more. Print 9 modulus 5. When we divide 9 by 5, it divided 1 times, but there will be a remainder. I think it's going to be 4, right? Yes. And now let's do exponential. Print. Yeah, we can write sometimes like this, multiply, something like this. Yeah, 2 times 2 times 2, but there is a case in which we should change that to exponential notation. So this is how we change it. So to the power of 3, and it's going to be 8. Okay, great. Now, using this arithmetic operation, we have covered arithmetic operation. In Python, we use this symbol to write comment. This is a comment itself. Yeah, so this part, this line will not be executed. What's the importance of a comment? A comment is actually to leave some remark or to make your code more readable. So you can put, for instance, this is an addition operation, something like that. So still it works, your code will work. So you should have a hash followed by some text, and that text is a kind of feedback or some remark. Great. Now let's move on to variables. Yeah, I can just right click here and create a file, variables dot py. What's variables, I think? What is variables? Yeah, what's variables? We will talk about variables. After variables, we will talk about data types. And also we will talk about further on operators, different operators. And then after that, we learn conditionals. And then we learn about a list. And then we learn about loop. And then we learn about set. Tuples. And dictionary. And then we talk about function, and that will be the end of the lesson. Yeah, good. Then let's start with variables. Actually, variables are containers. For instance, instead of writing print 1 plus 2, this means, of course, Python execute this, it give me 3, but it's not stored anywhere. So there should be a container. I should have stored it something like this. I have to store 1 at A, 2 at B, and then I can add them. I can add them like this: total A plus B. Now I can print if I want A or B or total. What's the total? I think you may expect when I am printing this, you may see 3. Yeah, 3 is coming from here. So this is a variable. We call this variable names. Variable names are actually just some characters. So for instance, if I want to store gravity, you can store it 9.81. So the word gravity is actually a storage, a variable that is storing this. Yeah. And then maybe if I give mass of a body of someone and 75 kilogram, then maybe you might be interested to know the weight of the body. So weight is equal to mass times gravity. And then if you print the weight of this person, and we don't know, but let's see. So as you can see, this person has this weight. Okay, maybe you may want to calculate the area of a circle. Yeah, usually we call radius. The radius of a circle, it could be 10 meters. And then what you should do is actually, well, how do we calculate radius? Usually pi times r, right? That's the formula. So we know this pi, it's 3.4, but first it's good to declare area of a circle, and then pi we can write manually 3.14, but what's the radius? It's coming from this, radius times radius. And even we can write this differently, just using like this, and print area, then we may get some value, 314. Yeah, 314. Great. Now this is a variable. At the same time, we learn some data type. Actually, the data type we have been learning so far are numbers. So then let's talk about data types. Okay, data can be found as in a form of what? It could be like numbers. Yeah, you love numbers, right? Numbers by themselves, they could be integers, and they could be float or they could be complex numbers, but we don't deal with complex numbers most of the time. We just love integers and float, and we don't have to worry about that. But numbers include in Python integers, float, and complex, and other data types also. For instance, string. String means any kind of text, and it could be a list, it could be a set. But before even that, actually, Booleans are really very important data types. Then here we talk about numbers, string, booleans, list, and set, tuple, and a dictionary, and none is also as a data type actually. So these are in Python. There are many data types, but these are the kind of the fundamental data types. Okay. Now since we talked about numbers already, how do we know if something is a number or not? There is a built-in function, a function already available here, type. It's a built-in function, and you pass something, the data type. For instance, if I pass 9.1, you may expect from this, of course, I have to print it out. If I print out this, you may expect a float because it's not an integer, right? No, it's not. So as you can see, it's a float. Yeah, that it's really working. It's a print type. For instance, 10. As you can see, 10 is a proud integer, isn't it? Yeah, it's great. Then print type, hey, oh yeah, hasta is what kind? Oh, is that so? It's a text. It's a name, and it's you have to expect it's a kind of a string. Yes, great. Now let's go for a Boolean data type. Booleans are actually true or false. Just only true or false. There's nothing else. And it's very important. It really helps us to make a decision. We compare something. If something is greater than or less than, so the value is true or false anyway. Yeah? If something is happening or not, then again, the value is going to be true or false. Then actually these Booleans, even though they are just their values true and false, any comparison result will be a Boolean. So now I may say just true. Yeah, of course it's going to be a Boolean. And again, print type and false. And then let's see, and it's again a Boolean. How about if I ask you this and type? Yes, and the 2 is greater than 1. The comparison of something, that is, now we are comparing two numbers, and definitely it's going to be true, and it's going to be Boolean, as you can see. Yeah, great. Now we learn maybe sometimes you may have an intention to store things, not just like this. Sorry, maybe sometimes we may want to store something like this in a list. Then if you see this, a kind of a list data type, or maybe sometimes you may store in a different data structure. Let me show you again that. For instance, 1, 2, 3, 4. I think this is a set, a collection of things or items. And then as you can see, it's a set. And sometimes you may use a different kind of data type, and that's going to be a tuple again, 1, 2, 3, 4, 5, whatsoever. And then if you see now this is a tuple, and now I will show you the last and the dictionary. And I think everybody loves in here Finnish language, and let's do a dictionary of a Finnish language. Okay, then I go for Kyria, and then it has to be a book, and maybe, and then I have to say koulu, and then it has to be a school in a Finnish English dictionary. School. And something else, maybe, yeah, this is enough. So how many keys? So it has key value, key value. Yeah, it's like that. For instance, if it's a country, country Finland, city Helsinki, population something. So a key value, that's a dictionary. Yeah, so this type of is a kind of a built-in function that allow us to check the type of uh, data type. Actually, at the very beginning, we start with a print. What the hell is print? Print is actually by itself a built-in function that allows you to print out something. So you don't have to care about that because it's already written for you to use it. But you have to know the concept of built-in functions. They are just for you to use. Later, we learn how to make our own functions. Okay, so now we have covered numbers data type already. Just to write down, as I told you, booleans are a value, print, you may say a true value, or print a false value. And these values can be found by comparison. For instance, we compare 2 and 1 and we got a true z value. When we do comparison, most of the time we get either true or false. So these Boolean values are so important. And so these are the data type. Most of them are numbers. And we saw these are integers and these are floats. And if you want, you can also check complex number, how it print a type of, and then if you write, for instance, 1 plus 2j, and this gives you a complex number. Let's see, it's a complex, but you don't use complex that much often, but I want you to know it exists, it's there. Okay, let's now go to string. Strings are so awesome. First name. It's, for instance, I can say name, okay, guys? I can say name and my name. But what is this name? Is this my middle name? Is it my first name? Or is it my last name? So I have to change this name to a first name, last name, or middle name. Then I should write it instead of something like a camel case, I have to use underscore, and that's convention for Python. Yeah, so whenever we have compound words as in a, a variable name, we have to make it as in underscore like this. Okay, last name. Okay, that is Itai again. Now I want to make my full name. I can just add the two names, first name plus last name. Okay, I can print this. Okay, print full name. Let's see. Now, as you can see, I found my name over here, but it's merged together. There should be some kind of a space in between. Yeah, we have to have that. Okay, then if you see, there is a gap in here. Okay, so you can put a space like this. And now let's see different methods of string. That is very powerful. For instance, we can change it to uppercase. We can change it to upper, we can change it to lower, we can change it to title, and I think also we can do quite lots of things, and we will see step by step. For instance, let's see print first name. If I just want to print my first name, as you can see, it is like this. But I can also change it to uppercase. First name dot upper. Upper is now omitted. As you can see, I had here a string and I attached something. So this is a method that manipulate my string. So you have to know the difference between, again, a built-in function and a method. A method usually comes next to a data type attached to. So we have this, an object, the first name object, and then it's connected there. And then it should change to something like this. How about print a last name? No, it's first name is okay, then two lower. I can change, and then if you see, then everything is lower. Print, for instance, I have I love Python. Maybe if I do this, and if I change this to title case, for instance, the title, it changed to actually a very good format. As you can see, I love Python. It was written like in a more like a very difficult way, but now this the title maker gives me by changing the first letter to uppercase. Great. A swap case, I think there's also print first name, for instance, dot swap case. The swap case, what it does, for instance, in my name, A is capital, but now with this, A will be lowercase and the other will be uppercase. Let's see. Yeah, so we swap something like that. So this is related to letter casing, but now let's do also a finding, for instance. Okay, but we can also use as in a roadmap of this, guys. I will just make use of everyone. And we're in string, as you can see. So you have to come here and also check what it has. I have to go a bit down and string methods, string concatenation we saw already, and we covered this one, and split string. Yeah, that is a very powerful thing actually. Let me show you. Then, for instance, I have language. Okay, our language now is the Python. So this is the variable, and this is the text. Yeah, print a language. If I do this, I will have just this. Okay, I have this split. If you split like this with this, that means you want to split this letter, this Python without any space. That means you want to chop it to letters or characters. Oh, is that how it goes? Okay. Yeah, with a space actually. Yeah, maybe let me try. I forgot that. Yeah. So it doesn't actually. So for instance, if you use just a split with this, it changes it to, as you can see, to a list. But if you have a couple of words in here, I love Python. Now, when you split it, you will have it changed to a word, as you can see now. Yeah. Great. But maybe now, let's see, how does it? No, I think I do something wrong. Exit. Okay, still it's an error. Okay, let me see what I have in here. Split. With some split the words at the comma if we want at the comma. For instance, as you can see here, I have a list of the language, list of language, print programming language. I think I forgot the P here. Programming language dot split at the comma, and then you may see it split it at the comma. Yes. Okay, let's keep going from the string methods. If there's some more methods, let's see these materials. By the way, this is not the end. Maybe you have to also go to check the 30 days of Python. For instance, as you can see, starts with, ends with. Those are actually very trim. I think trim is not here, but as this stripe. Let me show you, for instance, proper print. If you write I love Python, something like this, and there might be a space, right? If there's some space, then if you use the word, the method stripe, actually remove from the left and the right. Yeah, it's actually, it cleans these spaces, extra spaces from both sides. I think this is good enough. I will recommend you to go through 30 days of Python, or Python for everyone. This is a very small, and do the exercises. The exercises are very important. So now I want to move on to operators. Yep. Did we talk about operators? Yes, somehow. We talked about arithmetic operators already. And now I like to talk about comparison operators. And then after, logical operators. And of course, there are also different operators like increment and all those. But now let's talk about comparison operators, since we have covered arithmetic operators. Arithmetic operators means like addition, subtraction, multiplication, and all those what we have done here is arithmetic operator. So we don't have to do that all over again. But let's compare things. Okay, print, is 1 greater than 2? Of course, yes. Yeah, it's true. And the value, as I told you, the result of a comparison is usually a Boolean. And remember, that's why we have Boolean data types. We compare something, and based on that result, based on that Boolean value, we can make decision. Yes, what kind of decision? A decision that can change this world. Anyway, okay, anyway. So conditional statement, write some conditional statement. So what is 1 greater than 2? Yes, it's okay. Print 2, what, as you can see, 1 is greater than 2. That's false statement, and it's false. And how about if 2 is greater than 1? Of course, yes, true. Is 2 greater than or equal to? Of course, yes. Now let's do the other way. 1 is less than 2. And this is going to be also true. Print 1 is less than or equal to 2. Yeah, that's going to be true. True. And I think this is all the comparison operators we have, but maybe I think what I forgot to do, the equality. Is 1 is equal to 1? Oh yes, it's equal. But maybe let me introduce the bool something. Print 1. This, as you can see, Now this is not anymore a number, so it's a string. So we can't compare a number and a string. So this is going to be false. Oh, yeah, great. What do you think if I say 2 is equal to, yeah, oh, I think too much of this. Do you think this is going to be equal? No, of course it's not going to be equal. I'm just trolling you guys. Yep, no, this is false. Oh, great. Now let's see the logical operator. And we have these logical operators like and, or, not in Python. But something I didn't also, we can negate actually in Python also, print one is not equal to 1. This is true and this is false. The negation means it is not equal to. But even Python is so human that you can say print 1 is 1. That means 1 is equal to 1. Yeah, it's true. But you can say print 1 is not 2. Oh, as you can see, yeah, true. 1 is not 2. Yes, that's true. But if you say print 1 is 2, that's false. Great. It's somehow like, now let's get back to this, the logical operator and or not. Okay, so print 2 is greater than 5. Maybe I think the other ways, maybe 2 is less than 5 and 1 is greater than 0. As you can see, now we have two statement expressions, this one and this one. This is a true z, it's a true is less than 5, and 1 is greater than, that's true. True and true, the result is going to be true. Yeah, maybe we can just convert this one. 2 is less than 5, that's still true, but how about if you convert this one? So we have a true and a false, then it's going to be false. And how about if we have both false? 2 is greater than 5, that's really false, and 1 is less than 0, that's false. False and false, it's going to be false. So to get a true value with an AND operator, then the two expression has to be true. And now let's we can even change this to with or print 2 is less than 5. Yes, that's true. Or 1 is greater than 0. Yeah, this is true and this is true. Of course, it should be, the result should be also true. Yeah, great. Print 2 is less than 5, or 1 is less than 0. Now, this is false and this is true, but it doesn't matter with OR operator. If we have one true z value, it will be true. Yeah, great. Now let's do print. How about if we have two expressions with a false statement? And now, or 1 less than 0, and if I change this, as you can now, let's see, it's a false. So 2 is greater than 5, that's false. 1 is less than 0, that's false, and we got false. I think now we can also use the negation, like for instance, print 2 is greater than 1. This is true, right? But you can add here not, the not, and you can change it to false. As you can see, it's a false statement. Yeah. Great. So negation, the not operator can be used to negate. Even you can use double negation. And now not, and then this will be cancelled out, and you will have a true. Okay, guys, now you have completed this, the logical operators, all the operators, and then just let us keep moving. And now it seems that it's a very good time to talk about conditionals. Of course, I can create a separate file. Yes, what does that mean? Conditionals, or these conditions. In life, it's full of conditions. So you make decisions today. You decided to watch this tutorial or this lesson, and I believe you are having a great time. And thank you for deciding to come. Yes, what is the reason you decided to watch this video or this lesson? Okay, then you have to have a condition. To make a condition, we usually do something like this. We have to have if, and then the condition comes here. And then our code, we write it here. Okay, for instance, let me write a proper condition, okay? A is equal to 3, yeah? Then I may say, if A is greater than 0, print the number is positive. Yeah, as you can see now, I stored 3 at A, and now there is a 3 here. 3 greater than 0. Yeah, that's true. So this is a true Z. If this is true, then this will be executed. So I have to see the number is positive. But how about if I change this to -3? Nothing. Now you don't see anything. So it has only one condition. This works only when this is greater than 0. So we have to have another condition. We can add that with else. If this works, if this condition is true, do this one. If this condition is not true, go for this one. Yes, that's great. Then the number is not positive. Let's see. As you can see, then the number is not positive. Or you may say, actually, the number is negative. And now let's see. Then the number is negative. Okay, great. But how about if I change this to 0? Then the number is negative. Oh no, my condition doesn't work very well. Even 0 is not a negative, you know. So we have to have an additional condition, else if. So else if A is less than 0, we have to have something. Then I can say print the number is negative. Or now let's try again. Yeah, then the number is negative. Yes, because it's 0. It's 0. Now still I have to fix it. But if I, for instance, change this to -3, it should say the number is negative. But if I change it to 0, the number is negative. So this now, when it's 0, we have to get something else. Else if A is equal to 0, print the number is 0. The number is 0. And then let's check now. Yeah, the number is 0. But now if we put some different number, for instance, if I put a complex number, yeah, yeah, it was hard for, yeah, it was hard for this, for a comparison, for not supported between instance of complex and int. So that is not a very good test, but let's put a 2, okay? Again, not supported, uh, because we have to check such kind of comparisons. Now I am trying to compare this string here with the number, so it doesn't allow us. But anyway, this should be, I could say this one, it is not a number. And we will talk about how to handle these exceptions in other time. Okay, but anyway, now our if condition is actually working properly. If you see, so this, the number is 0. If you change this to 5, and it may say the number is positive. If you change it to minus, it may say the number is negative. And if you say this to 0, or if you change it, the number is 0. Great, now it's working. But let's make another more conditionals, and that will be the last. What's the weather today? Is raining. It's raining outside. I think in our case it was raining, so let's so after the lesson you have to have if is raining, true. And maybe it's better if you have take your umbrella. I think it's with you. Yes, it's raining, huh? So let's see. As you can see, take your umbrella with you because it's raining. But how about if I change it to false? Then yeah, there might not be. There's no, because it has only one condition. Then let's add else again. Great. Just go out freely. Freely as you are. Just go out freely, yeah? Just go out freely. Okay, but you know, the weather is not just rainy or shiny, it's more than that. And by the way, you don't have to equate this. You can just remove this because this condition just to check if something is true or false. And if it's true, this will be executed. If it's false, the other case will be executed. Now, I may say, instead of this, let's just say weather. If the weather is raining, then I may say, I may compare weather, rainy. And now, as you can see, take your umbrella. How about if it is sunny? Yeah, just go out freely. But now we have to add more else if, and then if the weather is cloudy, that means it's hard to know if it's going to rain or not. So print, I just take an umbrella in case it rains. You never know. Then maybe else if weather is really good, sunny, and then you may say print just go out freely and enjoy the daylight. Why is that? Too much E? Or too much? But what is that? Okay, good. Now, yeah, you can add more conditions, but this is good enough. For now, But this I can say, no one knows about the daily uh, condition. Let's run this. Just go out freely and enjoy the daylight because it's sunny. But how about if we want to get data from a user, we can get user using input, actually weather, and we can use this, the input that is inter weather condition. Yeah, and then we can get it from the user. After we get it from the user, we store it here instead of having such a value. Okay, that's great. Now I can run this and it will ask me, okay, and enter weather condition, sunny. Okay, just go out freely, it says. How about cloudy? Okay, just take an umbrella in case it rains. And then let me just run maybe rainy. Yes, take your umbrella with you. How about if I just do a typo, rainy, if I do. Yeah, no one knows about the daily condition. It doesn't matter if I write it this way or this way. Our code should work. So the easy way to make it happen, we can just change it to lower. Just change to a lower case. Then it will start working for any cases. Now let's run that again. And for instance, rain, like this. Some crazy. Take your umbrella with you. Now our conditional is working very well. And I think that is another is actually maybe we can write also some conditions ternary in Python. For instance, one greater than two. I think I forgot. Maybe I can ternary in Python. Anywhere I get. Yeah, the value here, if the condition else the value. Yes. If then you just do print something. This is true. Else print this. The else is true. The else is true. There's no way like that. As you can see, if this is true, then the if part will goes. If not, so now one is greater than true. So you may expect this. The else is true. Oh, I have to say something rainy. Yeah, the else is true. So as you can see, this is an alternative way of writing if condition, but you don't have to know this. But there is ternary operator, a one-liner. You can write your condition followed by the if, and if this is true, the if will be executed. If not, the else is executed. Yeah. So instead of having this, yeah, for instance, if you want for instance, you have a is equal to 5, right? You may say a greater than 0, then if print it is positive, else print it is negative. Yes, something like that. So it's the same thing. Let's try. This is coming from the previous. As you can see, it is it's positive. What we have lots of A0. I have to comment this out. Rainy. It's positive, but It is positive, it's negative. Where is it coming from? Do we have other? Yeah, because we have also other codes, and that's, let's comment this out together and reduce the number of what's happening. Raining. It's negative. Wait, why it's negative? It's negative. Okay. If a is greater than 0, that's true. And it should be positive. Else, even I see 2, and even I want to turn off this because I don't know the other value where it comes, because just no, I shouldn't see this. It's positive, it's negative. Okay. Okay, 1 is greater than 2. This is false statement. I should get, now this is the negative part. What's happening in this file? Okay, let me just let me just turn off this and do print what is happening here. Okay, it's good to figure out by just doing that what's happening. Okay, great. Then we can debug step by step. Sometimes when you don't know what to do, this is how you may solve. Just comment out everything and see what's at every stage is happening. So it's coming from this data. Now let me try if 1 is greater than 2, that's false. I'm expecting it should be printing this value. But for some reason it's printing both values, and that's not clear for me. How? Based on this, it's that the value, if, oh yeah, the condition has to be here. So I made a mistake, guys. The value we want to, and the condition has to come in here. So I made a mistake when I was writing the code. So it should be like this. The value, the condition has to come here. And this should come here. Yeah. Print something. Print something if this, else this. So I think we got some result this by chance. Now let's do this. Okay, it's negative. Yeah, because this is false. Now I may show you. This is a positive because now maybe I can make this greater than 0 if 4 is greater than 0. That's a positive, right? So I should get this is positive. Now you can also write ternary. It's a fancy way. Sometimes it's hard to remember it. As you can see, even I forgot how to write it, and then you can just Google and check how to write. I think we're done with conditionals. Now let's move on to list, and we will see how to write list.py. List is just a collection of items, a collection of ordered items. So you may have nums, and you may say 1 and 2, 3, 4. You have now, as you can see, 4 numbers. Print nums. And then you may see, as you can see, I have got 4 numbers. I just printed the numbers. We can also check their length using the len built-in function nums. And then if you run like this, now I got 4. Yeah, now let's learn how to extract them, just to take this out. By the way, they are arranged using index. So 0, 1, 2, 3. So index, 0 index, the 1, 2, and 3. Then if I say nums, and if I say 0, I am trying to extract out this value. Print 0. Then if you see now we have 1, then we can get actually the next nums, and then 1. You can take this out. You can go nums 2, and I can get this one. To get the length of the last nums, we can use actually index, because as you can see, I think, how do we do? As you can see, 0, 1, 2, 3. So the length of the array and the last index are almost the same, but the last index is less than the length of the arrays by 1. So we may say last index equal to length of the nums minus 1. Then we can make use of last index. Of course, we can just write the last index nums, and we can write just 3. But the problem is, for instance, if we have like thousands of items in this list, so it's hard. So now this and this give us the same value. It should give us 4. As you can see, it's 4. Yeah, great. I think why. Okay, now let's move on. And even sometimes you may use a negative indexing for, if we count from this, we start 0, 1, 2, 3. If we start from the other side, from the left side, minus 1, minus 2, minus 3, minus 4. So if I want the last value nums, and I can go minus 1, and I will get actually 4. Yeah. Then the other way, if you go print and say nums, and if you say minus 4, I think I'm going to get 1. Yes. So you can go negative indexing or positive indexing, but it's common to use the positive indexing, and you can get the last value using negative indexing. Great, now we learn how to extract. Now let's learn modifying the arrays. Yeah, we have 1 at the first. Maybe if I want to modify it, I can extract it by locating it, targeting it by index. I have a 0 and I'm actually targeting 1. So I want to modify it to be 10 or 100. And then let's print the nums. If you print the nums now, and you may see, yeah, the list is modified now, as you can see. Now I want you to modify maybe this, the last one, nums, a negative array -1, and if I change it to, instead of 4, I can change it to 400 or 4000 or 40 whatsoever. And let's see the value, print and nums. And I can just print out, and I should see a different structure. As you can see, 40 is modified. Now we learn how to modify it. You were mutating it, but it's a deliberate mutation, modifying the arrays. Okay, great. Now, how about if we want to remove one of the item? Yeah, print nums dot pop. Pop allow us to remove one item. So if you see now, print nums, as you can see, the last item has been popped out. The last item, yeah. So now we have 10, 100, 2, and 3. Okay, how about if we want to add nums that append? We can append, for instance, maybe 900 or whatever number. Okay, then you have to see by printing if it's modified or not. Then as you can see, 900. Okay, maybe we can add more. Maybe I want to add another number, 500. And if you see the added numbers here, yeah, great. But sometimes we may want to add multiple numbers, yeah. Then nums dot extend. This allow us to add list multiple items. For instance, 8, 7, 9, 200 or 300, whatsoever you want to add to that list, and print then nums. And then let's see. As you can see now, we managed to add quite a lot of items. Maybe I have to see more list, then I can't miss anything. So we have seen range. I will show you this. Yeah, one of the other methods is, for instance, last time I showed you, we have a Python, like yeah, great. In range, for instance, range, and if you put 10 here, actually the range method produce a number for you, yeah. For instance, this produces from 0 to 9. Okay, I can say here integers or numbers. I can store them numbers, and it's produce numbers for me from 0 to 9. So that means actually I have a chance to generate 0 to 9. But this is, as you can see, it looks like a kind of a tuple or something. Then you have to put this a list. The list is this constructor, the list constructor allow us, it's a list function again, and we put that value, and then it will change it to, as you can see, from 0 to 9. So if you want it to be up to 1000, you can see that we generate numbers from, yeah, of course, it's from 0 to 999. If you want the last number to be included, so just add additional one number. And even we can decide the starting. We can start from 0 and the default is also 0, or we can start from any point, for instance 1, and the step, the increment by default is 1, but we can make, for instance, by 100, so then it will not generate much number. As you can see, let's see. Now it was 100 plus 1 plus 100, 101, 101. Yeah, so the interval is now 100. So yeah, that's good to generate numbers. And a range, we will use it with loop quite often. So remember, it's very powerful to okay, creating a list, something I have to cover in the list. I think something I remember, for instance, we have a list, and if you have a string, like for instance, a Python, that's what, and this will be actually this, if you print out this, it is changed to a character of this, as you can see, yeah, Python has been changed to Python characters or letters. Yeah, I think this is good enough for now about list. And now let's start loop, and we will talk about for loops. But I think I can go to another file for loops in general, loops.py. Why we need a loop? You know, sometimes some activities are very tiring and repetitive, so it needs a loop. Okay, we've been talking about the list, and I checked 30 days of Python, and I think there are some methods we didn't checked, and I will take you to 30 days of Python. As you can see, list, I think this is really very structured. That's why, look at it, everything is really good. So I strongly recommend you to read it. List, this how you create, or this way. Most of the time we create like this, but you can also create like this, it's okay. So length of the empty list, checking the empty list, of course it's empty, it doesn't have anything, it's 0. And even as you can see here, we have a very good examples of list, and let's just practice using the examples that has been already made 100 years ago, okay, by someone. I'm just kidding. Okay, fruits and vegetables we have here. Actually, we can even do concatenation. Let me show you what's concatenation. Fruits and vegetables, the veggies, and let's just do it like this, fruits plus vegetables. And now if you print fruits and vegetables, you may have the list together. As you can see, banana, orange, mango, lemon, tomato, potato, cabbage, and onions, and the carrots. Okay, great. That is a concatenation. And we have also some lists of web technologies and countries, and if we need them later, we can manipulate them. But I think this is just an example here, how to just take them out and links whatsoever. And as you can see here, we've been talking about the index for the first item is 0. Or we can go the negative indexing, as you can see. Wow, this example is really good. So go for it. And then actually here also unpacking, as you can see, unpacking the list. For instance, we have here, let me unpack some of the items. Yeah, I can unpack. Do you remember here? I have here actually fruits and vegetables. From the fruit and vegetables, I can go, if you remember, maybe I think I can show you unpacking with a small example, a very little example. Nums. 1, 2, 3, 4, 5, 6. Okay. Now, if I want to get this out, I can say, maybe if I forget, yeah, we don't need any. Then what we should do? Okay, 1, 2, 3. Okay. And then if I say nums, by the way, now I managed to extract out 1. Now in 1 is stored. In 2 is stored. In 3 is stored. Let's check if that's true. 1, what do we have? Too many values to unpack? Oh yeah, so it says too many values to unpack. So in that case, what we should do, dot rest. Let's do. Now, as you can see, we have 1. 1 has been, and if you print also 2, you get 2. But what do you get in the rest? The rest is actually 1 goes to 1, 2 goes to 2, 3 goes to 3. Then the rest, that means 4, 5, 6 as an array. So let's try, or as in a list. Rest, let's see. Yeah, 1, I think that's not the value, 4, 5, 6. Yeah, great. So you can unpack the list like that. And for more information, please come and check this again. This fruit has been unpacked like this. Yes, great. Slicing, and slicing something we didn't see actually. So it's very important to know how to slice. For instance, if I want you to slice out the vegetables, only the tomato and the potato, it's going to be like this. You should say vegetables, and then you start from 0 and colon 0, 1, 2. Okay, the index is 2, but when we slice, it doesn't include this one. So let's do the print, and then by now, I should get tomato and potato from this line. Tomato and potato. Now, if I may ask you, hey guys, I need potatoes, cabbage, and onions, then I think you may write vegetables, and then where is the, of course, I have to have a potato. Yeah, there's nothing like potatoes in this world, right? Okay, 0, 1. 1, and then I got to here, 0, 1, 2, 3, 4. You should include the last 2, okay? Because if you just do 3, it doesn't include the onions. Let's see. Have you seen? Onions is not there. So you have to go up to 4. Great. Modifying list, we've been doing that, checking items. Yeah, checking items is also very important when it comes to list. And where is, for instance, we have countries. Let's turn on the countries. Oh yeah. So do we have Ethiopia in this countries list? Let's check. Ethiopia in countries. Okay, so if Ethiopia is there, this should be true. So let's check it if it's true or false. But as you can see, there's no Ethiopia in here. Okay, let's check, and if it's As you can see, it's false, but let's check Finland. Print Finland in countries. Then it should be true. As you can see, it's true. Great. So we call membership. So checking. Actually, even we can check as in a substring. For instance, print. Like this is how we write Python, right? Is there a thorn in Python? For instance, as you see, thorn, there is this Python, so this should be true. Yeah, it's true. Great. Now let's get inserting items into a list. Actually, then maybe sometimes you may have some you want to insert in between here. For instance, nums, right? I want to insert a number between 3 and 4, and I want that number to be maybe 7. I want to insert it. So nums dot insert. How does the code goes? Yeah, as you can see, the insert, the index in the item you want to insert. So nums dot insert, and the item is the index. Actually, you have to count it. Where is the index? 0, 1, 2. So at 2. You want to put it. So in place of 3, we are going to have that. But if you want to be here in between 3 and 4, actually we have to come up to 0, 1, 2, 3. Yeah, 3 and let's see 7. Then print nums. As you can see, in between 3 and 4, now we have 7. We managed to insert it, removing items from a list. So we have 2 ways of removing item. One is pop, that's for the last item, and another is using actually by the item name. For instance, if I want to remove maybe Estonia from countries, I may say countries dot remove, and then Estonia, and then maybe you will see here print and countries. If you see, then there's no any countries in here. Now maybe if you want to insert another country, you can insert the same way we did for numbers. Removing items using pop, we did that. Removing items using delete. You can delete the items by mentioning, actually, for instance, you can mention, hey, this one and delete. And you mention this one and delete. You can do it this way. As you can see, this also removes items, like a couple of items. For instance, if we want to remove now Denmark and Sweden together, I can say 1, 2, 3. So you have to say delete countries, and I have to go from 1, 2, 3, but it doesn't include the last one most of the time. So 1, 3, and let's see, print countries. As you can see, Denmark and Sweden has been removed. Finland and Norway is left. Great. Now clear items. So clear, if you want to clear, you just say clear. I think I can show you here. For instance, you have a list dot clear will clear out or wipe out everything you have in the list. And sometimes you want to copy. For instance, as you can see, I have a list, and then I want to have the copy of what I had. Then list.copy. Why I need to copy? A copy is so important because we don't like to work on the original data. Then that's really important. Then you may copy to avoid data mutation. So this is one way of copying. Okay, then joining with this is just adding together and so easy and straightforward. And extend, we have seen also, it's a way to add multiple elements to a list. Counting items in a list, actually, that's very important method in a list. Sometimes you may have some repetitive items. For instance, okay, let me see. Nums, I have this 1, 2, 2, 3, 4, 5, and 2 again. How many twos do I have here? At least I see 3 twos. Then you may say nums dot count. How many twos do we have? And let's print out, because to know I'm expecting 3. As you can see, it's 3. That's true. And counting items is really very important. Find index of an item. Yes, this is also very, very important. For instance, if you want the index of 24, you use index age.index24. So I should get 0, 1, 2. Yeah, as you can see, it is 2. The first occurrence, it doesn't matter about the rest. Okay, just give you the first index, the first occurrence. Reversing a list, we can reverse, by the way. If we have a banana, we just reverse this and it will be lemon, mango, orange, banana, the other way with this method. So easy. And let's do maybe that. Yeah, maybe I can do for you called print nums.reverse. Yeah, then after this we should see the other way. Yeah, the reason is you don't print this out like this, you just reverse it and then now print the nums. So what I'm doing actually, yes, as you can see, 2, 5, 4, 3, 2, 2, 1. We reverse that. Okay. Sorting a list. Sorting is actually we sort based on some order, right? For instance, if I want to sort the countries, let's comment out the deleting and the removing of countries, because then we have the full country. So now let's do a sorting. Countries dot sort, and then that means it will be arranged alphabetically actually, and then print countries. If you see Denmark, yes, D is before E and F, and Norway and Sweden. Can we, by the way, this even takes another reverse. Yes, true. Let's reverse it, the reverse order. Then Sweden, Norway, Finland, Estonia, Denmark. That's very powerful. But now the problem, the original data has been mutated, modified. So you have to be sure that do you really want to modify it, or is it by accident? So you have to know what you are doing. So, but now it's a deliberate modification. I modified it because I want to, and I don't have to have a copy now. I think that's good enough for a list, and let's move on the loops. And the loops allows you to do very boring, repetitive task. So for instance, if you have a plan to print hello world and 100 times, that's very tedious, very hard to do. So for I in range, we learned in range is just a kind of it just create a list of numbers, then it allows you to iterate. Okay, so it has a starting, I can make it 0 the starting, but by default the starting is 0, so the I actually starts from that. So print I, then this allows me to iterate from 0 to 9. Let's see, as you can see, it just iterates from 0 to 9. So I is actually an iterator. So can I multiply this? Of course, why not? Yes, you can. Uh, yeah, it's going maybe down. Yes, it's multiplied, as you can see. Can now, as you can see, 0 is the original, the initial, and the increment is also 1 by default, like this. Yeah. Maybe, for instance, if we want to start from 1, we can make it, we can start from 1. Why? Why we don't have to start from 0, or we can actually start from 1. And if we want to increment by 2, you can change it, and you can increment by 2, but let's just avoid this, and you can have 1, 3, 5, 7, 9. Actually, if you just look at this, it seems for me that these are odd numbers. 1, 3, 5, 7, 9. Yeah, so if you want to also just print only even numbers, this is actually an even numbers. Great. So how about if I was interested to do maybe some printing out countries? Maybe we can have some of the countries here, because if you remember, yeah, we can make use of that. Then what we do is actually, I can leave that at the top. We have a countries list. So Python is so friendly for country. In countries, print country, please. And Python is so nice and so friendly, and it print every country for you. And maybe I might be interested to change it to uppercase, because just to process it a bit. Yes, great. Maybe I may slice and maybe change a bit, and then 0 to, actually sometimes a string acts like an as in a list. So this is the first index, the second index. So I want to slice the country code, you know. So it's the first 3 letters most of the time is the country code. So I can go 0, 1, 2, 3, and then actually up to 4, or actually 3. Okay, then let's print this out, and then you may see Finn, Estonia, Dan, Sweden, Nor, and maybe you can even print this out as in an array. Why not? Just if you put, or at least, sorry, sometimes I get you, I say, then copy this in the other side, and then if you see, the printout is actually, oh, so it's a kind of a list. Then instead of doing this, maybe you can have some additional, some country codes, and just an empty list, as you can see. Then instead of just printing them out, actually you can also append them every now and then. Countries code dot append, and then just do this. By the end, we have to print it out outside the loop. Maybe if I put this, it will be easy for you. You see, print countries code, and then if you see now, you may see, okay, for Finland it's Finn, for Estonia it's Est, for Denmark it's Den, something like that. Maybe let's also do some like numbers. This one is so, for instance, if I ask you to add all the numbers from 0 to 100, quick, fast, and then you may say, okay, from 0, yes, in a range, so in range from, yeah, 0 to 101, because it doesn't include the last number, and that will be what this pin pony code. It's really annoying, so I have to pony code. Bye bye. Please, I will never get back because it's very annoying for some reason. Okay, then print, if you print this, it will be printing from 1 to from 0 to 100. So then instead, okay, let total, let's do 0, because sometimes when we start from the very beginning, our initial is 0, yeah? So then actually total is equal to total, and then adding that value every time allow us just to do that's a short code. We did it already, guys. Total, and then the total is actually the number from 0 to 100. That is 50 50. And if you want to change this to even, for instance, if I want to ask you to count it only the evens, then you just increment 0 to 4. And then if you see actually 25 50 is the even. I think now I will show you how to write a while loop, and then we finish the loop thing. Okay, while. Okay, let's just start counting from count 0. Yeah, so there should be a condition. While count is less than 11, print count, and every time I want the count to be incremented by 1, like this. And then I will show you, and now I managed to print from 0 to 10. How about if I want to do this the other way, from 10 to 0? I can change this to, hey, 10, as long as this is 10, and as long as count is greater than or equal to 0, and print, and every time just subtract 1. And this will allow me to do from 10 to 0 the other way. As you can see, 10 to 0. Now you know how to iterate in every direction. You can use this or the other. I can do also the same with the for loop. Yes, great. Congratulations for learning loops. That's a very wonderful feature of every programming. And now we have to move to functions. I know I'm going nuts, but it doesn't matter. Functions. Oh, yeah. Why? We need functions, Instead of having scattered code everywhere, instead we can actually pack our codes in a certain function, and that allow us to reuse the function, and also it's easy to test if we have a function that is easy to be used. Yeah, so for instance I can say def is a keyword that allows you to declare a function, and the name of your uh, um, uh, I think while loop is already covered. Def name of a function. Then you should have a curly bracket, this a parenthesis followed by a colon, and then your code goes here. Like it's somehow similar to the please. That's great. Then let me just do print hi. Now if I run this, it doesn't run, but let's just, because a function has to be called, okay, print this pony code is just annoying me again. Wow. Okay. So just let's call the function name of func. And let's run. Hi, great. Hi, if you just say hello world or hello Mr. Function, and then we have to call, so we call this declaration of the function, and here invoking or calling the function. But most of the time we return. If you don't return from your function, there is nothing there. Now if I try, I don't see anything because I have to also print this. Print name of fun, a name of whatsoever. Now hello world. Okay, now instead of name of fun, I call it print full name. Okay, then I think that makes sense. Print full name. Okay, my name is actually first name. It's yes, and my last name, and it's it goes like this, and you can do yours. And now I can just do full name, and then first name plus some space as we agreed last time, and last name. Great. Now we can just return the full name. If I just have you seen my name has been printed out. But if a function doesn't take a parameter, it's a dumb function. So it's not a kind of a function that use it quite often. So let's make it actually this one, taking like first name, last name. So it should really take something like that. Or you can just do it also like this. It doesn't matter if you just write it as in one word, or, and we don't need anything here actually. And now, as you can see, first name is coming from here, last name is coming from here, from the function, and the full name, and we are returning it here. But here now, you can say John Doe, and then let's see. As you can see, John Doe. I can make use of this function again for my name. Okay. And then it's like a calculator. Yes. Oh, great. Now we make our first function. That is how a function works. And even now, let's maybe make another function. Calculate weight of something. Sorry. Calculate of. So this should take a mass of a body and a gravity. And then, as you know, weight can be calculated as mass multiplied by the gravity. And then you just return the weight. Yeah. Then, for instance, print and then calculate a weight. For instance, the weight is it's going to be 75, 75, and maybe let's make the gravity 10, but it's not 10, I know, it's 9.8 something. Yeah, 750. But sometimes, you know, we can make, if we are on planet Earth, well, most probably we don't go to other planets, so we can have a default gravity, and we don't have to pass a gravity then. As you can see now, something like this. But now let's move on to another planet. Oh, come on, guys, because if you move to another planet, this calculates only for Earth, only for planet Earth. So you have to change, for instance, I think 1.65, either it's in moon or something, maybe gravity of 1.62, yes. So as 16.2, yeah, then now the gravity will be, as you can see, 102. The weight of the body is lighter than the weight on planet Earth. Yeah, so we saw here how to use a default value with a parameter. Sometimes there might be a need, and there is actually, you can solve quite challenging problems, and also to make your function somehow robust. Yeah, so it can be used. Okay, what else can I teach about functions? Sometimes lambda function. Yes, lambda is so beautiful. Lambda, you can say x, and then actually you may say 2 times x plus 5. So that means it's a kind of a function that multiplies. So this is the parameter, and then again we multiply the parameter by 2 and we add. But this can't be executed by itself, as you can see. It's just there written. Why? There anything wrong? Yeah, it's so to execute this, you have to store it somehow. I can store it with, for instance, a linear equation. Yeah, some linear equation. Okay, maybe it's good to write like this. Then I think in this print a linear equation. If I do this, I will print the function itself, because I am, as you can see, I'm printing the function itself, but I have to invoke it, and then I have to pass a parameter. If I to a value 2, then 2 will come here, and then since this is going to be used or equate here, that means 2 times 2, 4, 4 plus 5, 9. So I am expecting 9 now. Okay, great. Yes, guys, as you can see, it's 9. So now you know lambda functions. Sometimes with the higher order functions, you may need lambda, so it's very important. Yeah, great. And now let me talk about set. Set is one kind of data structure in Python. So we write set nums, for instance, 1, 2, 3, 4, 5. This is a num. This is the set set of numbers. It's not allowed to have duplicates. For instance, if I have 5, let me show you. And when you print out, you don't see actually 5, because it will be removed. What's wrong with this nums? I can have, yeah, because it's not a very good name. So sometimes set example. And sometimes when you use some reserved word like this, it causes a problem. So avoid that. 1, 2, 3, 4, 5. As you can see, yeah, there's no repetition. So to avoid duplicates, sometimes we use this. Yeah, can we look through the nums? Yeah, yes, for a num in the nums. And then, oh, sorry. Print nums. Yeah, of course I did. But instead of num, I did, yeah, 1, 2, 3, 4, 5. And the duplicate has been removed. Let's see the available methods for set. And it's very important to talk about the important methods. Yeah, this is how we create Actually, there's a typo here. This has to be, this is the how we create. This is more, it's for dictionary. Okay, this is how we create. Now we can check the links, len, because we have here, for instance, how many items, 4 items. So this should give me 4 items. Yeah, how many? 4 fruits. Accessing items in a set, we can we can't use index because this is not ordered, but instead we can use loops as I showed you, and also we can check if something is part of that. For instance, if mango part of this, yes, that's true. Adding is, as you can see, add item. For instance, if I want to add additional item, for instance, if I want to add nums, add just the 6, then if you add, now as you can see, I have 6. Maybe if we want to add additional stuff, for instance, or I in, for instance, 9, 10, 11, let's see, then we may say nums dot add I. That means now I'm trying to add multiple items. If you see, now I have 6, 9, 10, and 11 has been added to the set. Removing items from a set, we can use the remove and the name of the item. And pop can also help us to remove the last item. Clearing item in a set is somehow the same as clearing a list, as you can see, deleting the whole set. And finally, actually converting a list to a set. We have here the items, and then when you change to a set, actually the duplicates will remove. So it's very important to use this. For instance, let's see, banana, orange, mango, lemon, orange again, and banana again. Then there's no duplicate in the set. Joining, it's somehow similar to mathematics, union, intersection, symmetric difference. So the union of these two sets. So you just find the union, and also there is intersection between these two. For instance, what's the intersection between this and this? As you can see, we have 2 here, 2 here. Item, item. So the intersection will be item 3 and item 2 are the intersection. And even we can, as you can see here, Python and Dragon, they have something in common. There's O, N, O, N. That's the something in common is subset. If something is a subset of other set, you can use is subset. For instance, let's see, item 1, item 2, item 3, item 4. Item 2 exists here, item 3 exists here. So this is actually a subset of this. Yeah. So set 2 is a subset of set 1, true. But, and also set 1 is a superset of set 2. That's great. So to understand what I'm saying now, you should have a basic understanding of this elementary mathematics. Checking the difference between two sets, that is symmetric difference. That means actually A without B union, B without A kind of calculation. I think that's not very important. If you feel it's very important, you can go through the symmetric difference, as you can see, and then I try to put something here. Actually, A without B union, B without A, I think. So yeah, it's here. Here for some reason, here it was forgotten, but symmetric difference means this one. Joining set and disjoining set, to check if something is joining and disjoining set. If a set has an intersection, that's a joining set, and if it doesn't have any intersection, that's a disjoint set. So yeah, go and check it. Now let's go to tuples. Tuples is so easy because we can't modify it. And once we create a tuple, we can't modify it, and there's no much methods to talk about. Tuple is a collection of different data types, which is ordered and unchangeable and immutable. Oh yeah, so it doesn't change. If you once create it, it will be there. So you can't mutate it, you can't modify it. How do we create it? As you can see, we need parentheses like this or tuple like this. In two ways we can create a tuple. And as you can see, we have 3 items in the tuple, and I have 4 fruits in the fruits variable, and the length the same thing. And we can use index. It's an ordered item. As you can see, it starts from 0 and it goes to 3, 0, 1, 2, 3. And then we can extract it by index actually. And the other way, we can also use the negative indexing, as you can see over here, and we can do also slicing similar to arrays, or lists. We can do slicing. Changing tuples to list. Yeah, if we have a tuple like this, we can use the list function, and we pass our tuple and it will be a list. Then if you see this tuple will change to such a kind of fruit list. Yeah, checking an item in a list. Yeah, similar to a set or list. We can use the membership operator in if something exists in the tuple. Joining 2 tuples, yeah, the same thing. We can use this. This also works for a list, yeah. Deleting the tuple, then if we want to destroy it, delete and the name of the tuple, and you may check out the exercise. What is left is actually dictionary. Dictionary is very powerful, so let's go through the dictionary of this material. And this is how we create a dictionary, or the other way of creating a dictionary is I will show you here. We can create a dictionary like this. Empty dictionary can be created like this, or dict like this. Yeah, great. So we can create like this or with dict. As you can see, dictionary means a key value pair. We have the key and the value. For instance, you can see here, first name is the key and the value is the person name, last name and the value, the age and the person's age, the country and the value, is married, a Boolean value, skills, another list value, and address, another dictionary value, dictionary inside another dictionary in other language. In JavaScript, we call this just object inside another object. So yeah, can we check the links using the lane? Yes, we can actually. And then we can also use the like this, for instance, dict, and we can use the key Q1 under quotation, and we can get the value. That is how we extract the value out. And if we want to actually maybe yes, adding items to, if we want adding items to the value, for instance, we have this key, we call it key 5, or we can call it any country or city, and then the value, the name of the city or the country. So we can modify it like that. For instance, this dictionary didn't have a job title. Now I'm creating, hey, job title, go. That is here. And then skills, as you can see, skills this person has, but actually I am appending some skills and mutating the skills inside the person dictionary. So that's how you mutate, add or mutate what's happening, what's existing already. Modifying items in a dictionary. Now, for instance, I have also here Q1. Maybe I want to change the value one here to something a different value. Then this is how you modify the dictionary. Sometimes when we try to use this method, if the value is not there, if the key is not there, it may goes wrong. For instance, name doesn't exist here. If I search, if I use name keyword here, it may raise an error, so it doesn't run, the code doesn't run. So instead, we can use actually a better way is actually the get. Get, if the city, for instance, we don't have city in this city, so the value is none. It doesn't crash. Instead, it gives you something, some value. That's the most important of get. Get. And then changing a dictionary to a list of items. Yeah, so if you just change dict to items, it will be a list of items. And the items are actually the tuples, and the key and the value, and the key and the value. Sometimes we may need to change that. Clearing a dictionary. Okay, we can just dict.clear and it will be cleared out. Or delete, completely deleting. And copy a dictionary, dict.copy. Sometimes if we don't want to mutate the original dictionary, getting dictionary key as a list, we can say dict keys, and we can get only the keys as in a list, or the values, we can say dict.values, and we can get all the values of the dictionary. I think this is good enough, and if you manage to listen to from the beginning to here, you may have a very solid understanding of Python. That means you know how to install the Python programming language on your local machine, and you know how to run the terminal by writing Python version. You know how to check, and you know how to start the interactive Python shell, and you can write code over here, and you can close it, of course. And not only this, actually you know how to use a very fancy code editor like VS Code, and also you know about variables and how to comment, and you know how to write operators, different operators like arithmetic operators, logical operators, comparison operators. And in addition, you know, list is very powerful feature of programming. Now you know everything about Python lists. In addition, you also learned about other data types, data structures like set, tuple, dictionary. And in addition, we have covered also conditionals. Yes, conditionals are very important for decision making. Yeah, without condition, it's almost impossible to write a program. And now you know how to write different conditions. After all, now you know how to write functions, and I believe you know how to write a very clean functional codes. Thank you so much for watching, and